Okay, so we're working on 5.4, the last section of this very short chapter before the test on Friday. So this is just about our shortest chapter, won't cover as much material. So as usual, this is what you turn in for homework. You can see it's not that much compared to, let's say, the last chapter, which was on trig. It's quite big. So I think this is literally our shortest one. And the last one isn't going to be that long either. Okay, so I think we're good. However, these are all word problems. Okay, so it takes a while to work your way through the word problems. So get comfortable on your calculator with the ln button and the e to the x button. Okay, whether you have a graphing calculator or an ordinary standard scientific calculator, ln and e to the x. So you'll be using that quite a bit for these. So make sure you know how to do them. Okay, so I only did one problem last time, so I'll just check it off. But we'll be doing more. Okay. All right, so 5.4. The basic formula that you want to put on your cheat sheet is either the one that's in the book, Q of t equals Q0 e to the kt. It's on page 305. But again, Q might be A of t equals A0 e to the kt. It might give you P for population. P of t is P0 e to the kt. It doesn't really matter what the letter is. Okay, this is the initial amount. The 0 means time 0 at the beginning of the experiment. This is the new amount. E, we know, is the base for natural logs. It's like 2.7. K is a constant. If K is bigger than 0, then Q grows exponentially. If K is negative, Q decays exponentially with time. T is time, as you might expect. And the time can be given in any unit that you want. It could be minutes, seconds, hours, days, years. It depends. But whatever it is, just keep it for that entire problem. Okay. All right, so you can see all the word problems we have to do. So again, I'll try to keep going as many evens as possible. Okay, so last time I just did number 2, right? So let's try for number 4. Okay, number 4, I'm on page 310. That bacteria culture started with 8,500 bacteria. Okay, so that tells me right away A0, my initial amount, or you can say P0 for population, or Q0, quantity. Increased by 15% in the first 2 hours. Now, increase by 15% means I'm going to multiply by 1.15, and my time is going to be 2. Okay, so 8,500 is going to be my initial amount. Find an expression for the number of bacteria T hours after the culture was first observed. Then all this other stuff. Find the number of bacteria that will be present after 8 hours. When will the population reach 35,000? How long does it take the population to triple in size? Okay, so a lot of things going on. So the first thing I'm going to do is figure out when it says increase by 15%, I multiply by 1.15. Or you can multiply 15% plus the 8,500, but it's easier to just multiply by 1.15. Okay, so I'm going to keep the book somewhat handy, but go here now. Okay, so A of t is A0 e to the kt. This will work for all the problems. If A is amount, the amount might be bacteria, it might be a population, might be money. Okay, it can be anything. So I like to use A of t, A of A0 e to the kt. Okay, they told me the initial amount was 8,500 in the words, right? So that's going to be my A0. Then I plug in 2 for the time, increased by 15%. I multiplied by 1.15 and I got 97.75. Okay, A of 2 is 97.75. Okay, that's 8,500 times 1.15. Okay, so in other words, 8,500 times 1.15. Sorry, 97.75. Sorry if I aim the calculator the wrong way, that kind of burns out your eyeballs. 97.75. Okay, so I plug all that in to figure out the K. So the new amount, A of 2 as a function, the amount at time 2 is 97.75. That goes there. 8,500 is the initial amount. E to the K, 2. So for K, so you should know how the game works by now. Divide by 8,500. Okay, this is 1.15, no big surprise. We knew that was going to happen. Equals e to the 2k. Take the natural log of both sides. Okay, and I know I'm not testing you on how you say it or vocabulary, but you don't multiply by ln. This is not a multiplication. It's the application of a function, the natural log function. So you're not really multiplying here. You're applying ln of e to the 2k. Ln e cancel out. So ln 1.15 equals 2k. Divide both sides by 2. So k is ln 1.15 divided by 2. It's approximately 0.0699. Okay, I'll use this many digits. Now, if you want, greater accuracy, you keep every single digit. If you ever need that accuracy, you probably, just leave it on the computer, let's say. Chances are for what we're doing, we don't need that great accuracy. So you don't have to put every single digit. But, I'll not mark you wrong if you put every single digit, but, you don't really have to for most of these. 0.0699. And just for fun, let me see what I get if I type in all the digits. .0698809.7, whatever. Okay, so round it up to 0.0699. 06988 means 0699, almost 0.07. Okay, so the equation is now A of t is 8500 e to the 0.0699t. So that's the answer to part A. Find expression for the number of bacteria, blah, 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 blah. Okay, now that I have the equation, here's the key thing. If they give me any time, plug it in here. If they give me any amount, plug it in here. Okay. So notice, find the number of bacteria that will be present after 8 hours, plug in t equals 8. C, plug in 35,000 to the left-hand side to the new amount. Let's see, where did I go? Yeah, A of t. And then D, how long does it take for the population to triple? I just triple the original amount. The original amount was 8,500. I just multiply that by 3, and that gets plugged in. Okay, so part B, plug in t equals 8. Right there, A of 8 is 8,500 e to the 0.0699 times 8. Punches in your calculator. I'll save time, just go right to it. For bacteria, round to the nearest whole number. Bacteria, populations, people don't have any decimal or fractional amount. So I got 14,867 bacteria if you punch it into your calculator the right way. And of course, double check that you can do it yourself. Right? Obviously, just don't take my word for it. Make sure you can figure it out yourself. Let's see. C. When will the population be 35,000? So 35,000 goes in to the left-hand side, the new amount, A of t. Okay, it's a different population than the initial. So we retrace our steps, sort of. 35,000 equals 8,500 e to the 0.0699t. Divide by 8,500. Okay, I reduced the fraction to 70 over 17. That's probably the best. I didn't want to keep all those decimal digits, so the most accurate is put 70 over 17. So 70 over 17 equals e to the 0.0699t. To get rid of the e, ln, natural log both sides. So you see a recurring theme quite a bit. So like I said, get comfortable with the ln and the e to the x. Be doing it, a lot this section. Okay, so divide by 0.0699. So t is ln 70 over 17 divided by 0.0699. Now I punch it in my calculator. Okay, and can time come out to be fraction or decimal? Sure. Okay, so we don't want fractional bacteria, fractional people, something like that. But for time, sure, it can be a fraction or decimal. So 20.25 hours, 20 and a quarter, so 20 hours and 15 minutes, I suppose, is one way to say it. So that's the answer to part C. And then D. Let's see, where'd it go? Lost my place here. How long does it take the population to triple in size? Okay. So I'll just triple the original amount. Okay. What was the original amount? 8,500. So just multiply that by 3. and you get 25,500. Okay, so part D, triple. So I start out with 8,500, 25,500. So it's really the same question as C with a different number, right? They're telling you 25,500. So 25,500 goes here instead of the previous problem where it was 35,000. So 25,500 equals 8,500 e to the 0.0699 t. Solve for t. Divide by 8,500. This side is 3. Hey, no big surprise, right? That's how we first got it. We got it by multiplying this thing by 3. So 3 equals e to the 0.0699 t. ln. Notice a common theme shows up over and over and over and over again for these kind of problems. Okay, ln and e cancel out. Natural log of 3 is 0.0699 divided by 0.0699. Punch it in your calculator. 15.72 hours. Again, a fractional time is fine, or decimal time is okay. So 15.72 hours. Okay, and I'll just mention something quickly on the calculator. Again, so just to rehash that concept. So on my calculator, ln 3 divided by 0.0699, 15.71, so 72 rounded off. Okay, and again, some of you, when you hit ln, it automatically gives you a left paren. I just typed that in. So you folks will have to close it with the right paren. Sorry. Oh, that's a little bit better. I have to raise it up though. And divide it by 0.0699 equals. Okay, so again, if your calculator, once you hit ln or several other functions, it automatically gives you the left paren. Got to close it with the right. And for your calculator, the same thing happens if you were to type sine, cosine, tangent, square root, same thing. It will automatically give you the left paren. Then you have to close it with the right. My calculator, if I just hit sine, it just shows up sine, so I don't have to worry about parentheses. So just go to it. Again, for those of you that have a backward calculator, the regular scientific calculator, so you folks, you'd have to do 3 ln backwards. So hit 3 and then ln, which is over here. Okay, so there's 3 ln and then divided by whatever. What am I dividing by? 0.0699. So divided by 0.0699 equals, and there we are, 15.716, which I rounded up to 15.72. Okay, so I think I've covered most calculators. Now, if you're not sure how your calculator works, then, let me know. Or come see me office hours or send me an email. We'll try to work it out. All right, so that's number 4. Okay, let's move on to number 6. A certain radioactive substance, so this is decay now, has a half-life of 8 years. If a sample has 200 grams of mass, find an expression for the mass after T years. How much of a 200-gram sample will remain after 15 years? How long will it take for 90% of the sample to decay? All right, so here's a decay situation. So as time goes by, the substance is losing its amount because it's sending out radiation, radioactivity. Okay, and a lot of substances decay with something called a half-life. Okay, so let me take a quick time out and talk about half-life. All right, so a half-life of a substance is defined to be the amount of time needed for a substance to reduce to half its amount. Okay, and I got a little table here for practice. Okay, so suppose the half-life is 3 years of a particular substance. So here's time in years, the amount in milligrams. Okay, let's pretend we started with 8 milligrams. So where'd you get that from? I just made it up. It's completely made up. Okay, half-life is 3 years. So after 3 years, I would have half of 8, which is 4. Okay, and well, I should have covered this up. It's too late now, but here's the tricky thing. This is not a linear relationship, meaning you might think, oh, after 3 more years, the other 4 is gone, so it's all gone. It doesn't work that way. Okay, it doesn't work that way for exponential decay, right? So if this were a straight line, you would say, well, 3 years, half of it is gone. So after 3 more years, the other half is gone. Nope, doesn't work that way. Okay, it's proportional to the amount that's already there. So after 3 more years, you would have half of this amount, which is 2. That's the way it works. So can you guess what happens at the 9th year? How much is left? Half of 2, which is 1. Right? And how about 3 more years? 12, 0.5, and so on, 0.25. So that's the way it works. So at any moment in time, after 3 years of that, you would have half of whatever the amount was at that time. So half of 8 is 4, half of 4 is 2, half of 2 is 1, and so on. Okay? So that's called the half-life of a substance. All right, so how do I use that in this particular problem? So for problem 6, the half-life is 8 years. All right, a sample mass has 200 grams. That's my initial amount. Okay, so my A0, A of t, so using this formula, A of t is A0, 200, e to the kt. Now, after 8 years, I have half the amount. So I plug in 8 here, I put 100 here. Now you say, where'd you get that 100 from? Half of 200. Whatever this was, right? This could be 1,000,000. This would be 500,000 after 8 years. This could be 26. This would be 13 or whatever, right? Half gets reduced after 8 years. That means after 8 years, the original 200, what was it, 200 milligrams or something like that? 200 grams, it becomes 100. All right, solve for K. Divide by 200. This is a half. On my calculator, it's easier for me to type in 0.5, so I'm going to put 0.5 as opposed to 1/2. In fact, you'd have to go parentheses 1 divided by 2, right? So for me, it's a lot harder to go like this, parentheses 1 divided by 2, parentheses, right? It's a lot easier for me to just hit 0.5, right? I think most of you would agree. So 0.5 equals e to the 8k, ln. See, after a while, you just do the same stuff. Okay, a lot of ln and e, right? Which means we're not going to do log or 10 to the x very much right now. It's almost all ln and e. Okay, so ln 0.5 is 8k. After the ln and e cancel out, divide both sides by 8. K is ln 0.5 divided by 8. Punch it in the machine, negative 0.0866. Okay, and by the way, that does confirm that this is a decay situation. The constant should be negative. So as time goes by, you started with 200, right? So if it's a growth, like money growth or population growth, it would go higher, like 250 or 300 or whatever. But this is a decay. It goes down as time goes by, which means decay should be negative. And you know it is. Plug that back into here. So A of t is now 200 e to negative 0.0866t. And again, that's just confirm that in case some of you want to see how I got that in a calculator. ln 0.5 divided by 8, negative 0.0866. Whoops, sorry. Or again, for your calculators who need it, whoops, sorry, that have the left paren, close it with the right paren. Or again, some of you have to hit backwards. You have to hit 0.5 ln, right? And then divide it by 8. Okay, so this is the equation. So find an expression for the mass after t years. We got it. So A of t is equal to 200 e to negative 0.0866t. And I guess I'll call that A. I didn't write it here. Oh, I wrote it up here. There we go. I called it A. Okay, then part B. How much of a 200-gram sample will remain after 15 years? I plug in 15 for t. So 200 e to negative 0.0866 times 15. Okay, and it comes out to be 54.53 grams. Okay, for word problems, if you know the units, you should write the units. And let's see, I should show you at least once how that goes. So 200. Now this time you want E, not ln. So on most calculators, it's second function E to the, where'd it go? Negative 0.0866 times 15, close parentheses. Okay, so here's how I'm typing it out. Sorry. 200 e to the negative 0.0866 times 15. Okay. And I wrote it wrong. Okay. So what was wrong with what I wrote? Let me start over. 200 second function e to the parentheses, what was it? Negative 0.0866 times 15. Whoops, sorry. There we go, 54.56. I guess 54.53, rounded off, crossed up too many digits. But anyway, that's that. Okay, then part C. C, how long will it take 90% of the sample to decay? Well, what's 90% of 200? 180. So it's just like saying, when will there be 180 grams left? Okay. Oh, I'm sorry, let's see, 90% of the sample to decay. Ah, I got it wrong. 90% decay means only 10% is left. Yeah, sorry about that. Okay, first I interpreted as 90% left, but no, it loses 90%. How long will it take for 90% of the sample to decay? Right, so 90% is gone, that means only 10% is left. So what's 10% of 200? 20. Here we go. So it's just like saying, I want 10% left. Okay, so 20 grams is left. Okay, so 20 equals 200 e to the negative 0.0866 t. Divide by 200. 0.1. 0.1 equals e to the negative 0.0866 t. Take the natural log of both sides. That cancels out. Same old stuff. After a while, very repetitive, so to speak. ln 0.1 is negative 0.0866 t. Divided by negative 0.0866. 26.59 years is my answer. Okay. All right. Number 10. A little bit shorter problem. There's less to it, I guess. Yeah, that's it. Just that little part there. But it doesn't mean it's short. Find the half-life of a radioactive substance that decays by 5% in 9 years. So this is not a half-life, it's a 95% life, so to speak. So how do you do that? Notice they don't even tell me the original amount, right? It doesn't say, oh, do you have 100 grams or 500 kilograms or whatever. They don't tell me, which would lead us to believe that you don't need that information, and that's true. You don't actually need that information. Okay. Well, how do we do it? Find the half-life. It decays by 5% in 9 years, which means you keep 95% after 9 years. Right? I'm going to keep switching back and forth with the book because it's a word problem, so you have to keep looking at this. Decay by 5%. That means you keep 95%. Is that right? Why is it yellow here? So you keep 95% in 9 years. All right. So here's what you do. A of t is A0 e to the kt. We know we're going to plug in 9 right here. What goes on the left-hand side? You keep 95% of the original. What is 95% of the original? 0.95 A0. So even though they don't tell me the A0, they don't tell me the A0, just put 0.95 A0. 9 goes there. So 0.95 A0 equals A0 e to the k times 9. Okay. I'm just going to divide both sides by A0, which means it doesn't matter. So that confirms the fact that it doesn't matter what A0 is. Well, as long as it's a positive quantity, you can't divide by 0. But if A0 is 0, that means you don't have anything to begin with. So we're not talking about anything. So under the assumption that there's some positive quantity, divide by A0 and it's gone. So yes, for these kind of problems, it turns out not to matter what the original amount was. Whether you have 1 milligram or 1,000 tons or whatever, it doesn't matter. We're just going to divide it off. Okay, so 0.95 equals e to the 9k. ln both sides, same stuff. Natural log, cancel, cancel. ln 0.95 is 9k. Divided by 9. K is ln 0.95 divided by 9. Approximately negative 0.005699. Okay? And every now and then I'll show you on the calculator. So for those of you that have the backwards type calculator, right? So again, you folks have to hit the number first, 0.95, and then ln backwards. And then divide that by what? Divided by 9. Whoops. Divided by 9. Negative 0.005699. Blah, blah, blah. Okay. So that goes up here. A of t is A0 e to negative 0.005699t. 6 there. Now, how do I answer the question? What is the half-life? Find the half-life. Same as what I just went over. Half-life means I put 0.5 A0 or 1/2 A0. Okay, so now I got the equation to be like so. So how do I figure out the half-life? Take half of the original amount. There it is. So what was the original amount? It doesn't matter what's the original amount. Half of it is 0.5 A0 equals A0 e to the negative blah, blah, blah t. Solve for t. So once again, you don't really need the A0. Okay, divide by A0, it's gone. ln 0.5 is, oh, sorry, ignore the red temporarily. But yeah, I get ahead of myself. After a while, it's kind of like, you already know there's going to be an ln there, so I just put it. So I had to stop myself. So 0.5 equals e to the negative blah, blah, blah t. Now take the natural log of both sides, right? So ln and e cancel out. Natural log of 0.5 is negative 0.005699t. Divide both sides by negative 0.005699. Approximately 121.62 years. Positive, not negative. Okay. You might look at this and you wonder, hey, there's a negative there. Shouldn't the answer be negative? The answer is no, because ln 0.5 is also negative. So you have a negative divided by negative, so we're okay. Okay, so yeah, I'll go ahead and show you that. ln parentheses 0.5 divided by negative 0.005699. Sorry. Sorry. ln 0.5 divided by negative whatever. 121.626. 121.62 years. Okay. Okay, and I'm just going to show you just one more, then I'll be done for today. You can see, so, I said we only had one more section, but it takes a while to do these problems, right? They're not fast. They're not just like, oh, what's the sign of pi over 6? Figure it out quickly. These problems take a while. Okay, I'm going to jump down to 14 because it talks about money, building money. Okay, so 25,000 is invested in an account that returns 7% per year, compounded continuously. How long will it take for the investment to double and to triple? So that's often asked for. So you have $25,000, 7% is the interest rate, compounded continuously, double and triple. It turns out you don't even need the 25,000. You can just leave it as A0, but since they gave it to us, let's do it. Okay, 25,000. The interest rate was 0.07, 7% compounded continuously. Again, yeah, 7% per year compounded continuously. Okay. So I'm going to make a note to myself. All right, so first it says double. I want 50,000. Triple, 75,000. Right? So 50,000 and 75,000. I left off the triple part. I'll let you figure that out, but it's the same concept. So 50,000, 25,000 e to the 0.07t. This is kind of like the doubling time. Okay. So we had half-life, right? Something decays in half. This is the other way around. It's doubling. I want my money to double. How long does it take for my money to double? 50,000 equals 25,000 e to the 0.07t. Divide by 25,000. This is 2, no big deal. So I didn't bother to do part B, but you can do part B on your own. It'll be exactly the same. Instead of a 2, you're going to end up with a 3, right? Because instead of 50,000 for part B triple, you're going to have 75,000. And then the logic is the same. The math is the same. Right here, you would have 75,000. So after you divide it by 25,000, this side would be 3. So just follow the template exactly the same. So 2 equals e to the 0.07t. Take the natural log of both sides. Again, technically, you don't say multiply by ln. Okay, you take the natural log of both sides. ln and e cancel out. ln2 is 0.07t. Divide by 0.07. 3.35 years is my answer. Okay, and then triple, you do the same thing, except this would be a 3 over here. All right, and that's as much as I was going to do today. I still have tomorrow to do some more evens and then maybe let you ask some questions about odds that are here. Okay, but otherwise I'm done for the day, folks. Let me stop the share, check the chat. Am I going to do more tomorrow? Yes. So I'll try to do the rest of the evens and then let you ask some of the odds as we go by there. Unless anybody wants to see more today, we can do that also. Okay, but that's all I was going to do today. Anybody have a question for today about any of these, or does anybody want to see any of the other ones? Okay, and my phone's ringing, which wasn't supposed to happen. So maybe that tells me it's a good time to stop. Okay, any other questions? Otherwise, we're done for the day, folks. Okay, that'll do it. So everybody have a good day. I'll do more problems tomorrow. Thursday, questions and answers, and Friday's a test. Okay, all right, have a good day, everyone. Thank you.